Lots of reading. That's what this one is. Lots of reading. Okay, we're in a math class, so reading is everywhere. So don't rule it out. All right, a basketball player takes a jump shot from about the free throw line. In doing so, this player elevates so that he releases the ball from 10 feet high in the air. Okay. The horizontal distance from the shooter's hands is considered X, while the height of the ball from the floor is Y. It is determined. Now, guys, as I'm reading this, I'm like pointing, like labeling things in my head. Like, okay, we got X. We need to know what X is. We need to know what Y is. I know that 10 is what? Is that an X or a Y?
It's the Y.
Yeah, so that's a Y value right there. And you might write it down on the side. Maybe you write it down right here. You got X, you got Y. Maybe you write what they mean, like X is horizontal distance, so I'm just gonna write horidist, and Y is height. And we know a value of Y. We know that Y equals 10 at the very beginning. Okay, so translating. Oh wait, 15 feet. What's that? That's another number. What is 15? It says 15 feet from the basket. That's a horidist. Okay, so let's write that down too. So now we know X value, and X value is 15. All right, now let's finish reading because I don't even know what this thing wants. It was determined that the ball follows the path described by this equation. That's a nasty looking thing. Answer the following questions. Oh, and by the way, that is definitely important too. I don't want to not highlight it, but I suppose you don't have to. Answer the following questions. Knowing a basketball hoop is 18 inches or 1.5 feet in diameter. 18 inches. Okay, hold on.
Oh.
We're using feet right here. Okay, that was nice of the problem. Because we're using feet, this one says 18 inches, but it also said the units in feet and diameter. You guys know what diameter is? Diameter.
Yeah.
Jeez. Oh, nope, wrong one. Okay, so we got this. Diameter would be from here to here, right? And that's 1.5 feet. All right, not sure if that's valuable. Okay, about 9. Okay, basketball is about 9 inches. Oh, they don't give us the feet for that one. That's mean. 9 inches. Well, let's see. How will we convert that to feet? So 9 inches. If we want to make that into feet, won't we have to multiply that by 12 inches and 1 foot on top? So that way the inches cancels out, and we're left with 9 over 12 feet, which simplifies. See, feet is left over, so I'm going to write feet right there. That simplifies to 3 over 4, so it's 3/4 of a foot, which you guys know the decimal of really quickly, don't you? 0.75? All right, very nice. Okay, now let's read our first question. The basketball has traveled 1/3 the distance to the hoop. Okay, 1/3 is probably important there. I'm just going to write 1/3 above it. All right, it says, how far above the ground is the basketball at that point? Show your work. 1/3. How far is the basketball from the hoop? The horizontal distance?
15.
That's 15. Okay, what is 1/3 of 15? So I have 1/3 times 15, and you guys know that's 5. Because, it'd be 15 over 3, you get 5. So, how high is the ball? Let's see. How would we figure that out? Okay, this is an X value. How would we find how high the ball is? So we're looking for a Y value. Man, I wish there was something that related the X's and the Y's together. Oh, snap. There is this equation right here. So let's do that. Let's plug the 5 into this to find the height of the ball. You want to know what Y is? I'll tell you what Y is. Y is whatever you get when you plug this stuff in. So we have 5 right here, and we're going to square the dude. And then we're going to go 1.5. We're going to multiply that by 5. And then we're going to go plus 10. What's that? Doesn't it say? Oh, it's negative 0.1. Sorry. Thank you. Okay, so this is 25. And what is 25 times 0.1? That would be negative 2.5. Yeah. And then we have 5 of these. Oh, man. I know 2 of those. 2 of those is 3, right? So that means 4 of those would be 6. And then 1 more of those would be 7.5. Plus 10. Oh, man, we're doing all these decimals in our head. What is negative 2.5 plus 7.5? That'd be 5, right? So that's 5, and then 5 plus 10, 15. So 15 feet. Yay. It says, if the basketball hoop is 15 feet from the free throw line, which we already knew, we wrote it down, and 10 feet off the ground. Wait. What's 10 feet off to the ground? The basketball hoop? Oh. Didn't he release it at 10 feet too? I don't know. I say he, but it could be a she, I suppose. It does say basketball player. Off the ground. Then is there a reasonable chance that the player makes this particular shot?
No.
Ooh. That's a good question. How do we know that?
You're gonna tell us.
Okay. Let's do a little bit of thinking. So the basketball player jumps. I don't know if he jumps like that, but he jumps and it's like woo! And there's a ball right here. It's about to go in this basket. He releases the ball at the same height as the basketball hoop. That's what it says.
Well then, no. I think
doesn't.
When he releases it, but he's throwing it. It's going to go higher.
Maybe it's a bad picture. Maybe it needs to go up higher.
Don't we just plug it in?
I think this math problem is a little bit unrealistic.
Okay. Oh, wait. It's a negative. It's a negative parabola, right?
So it'd be like this.
Couldn't it be like, right?
Oh.
Couldn't that happen?
Yes.
Okay, my ball's a bad one. You guys are just like, oh my gosh. What if it was following this path?
Correct.
Right? Mm-hmm. So wait, how can we actually know if it will make it?
Plug it in.
You plug the 7.5.
Okay, we know the distance right here, like where he released it to here. You guys know that, right? That's 15.
I need visual.
We also know that the distance right here is 10, and the distance right here that he released it is 10.
Wait, no, I don't.
Okay.
Oh.
Is that true? Like if we, what questions do you have when you see that? My question is, if I go 15 away, will this ball be 10? Because if we related this horizontal thing to this vertical thing, right? Depending on, we did 5, right? And how tall is this at 5? At 5 feet. At 5 feet, it's 15 feet high? Oh, there's a lot of 15s around here. I'm not sure if finding the vertex would help, because what if I drew my parabola wrong? What if the ball is described by this parabola? So technically, it's not going to make it. The vertex now is right here, instead of the vertex being right here. So will knowing the vertex help us know if this ball is going to make it?
No.
I don't know.
Maybe not.
Can we know though? Can we know how high the ball is at 15? Wouldn't that help? At 15, if we knew how high the ball was, wouldn't that tell us if it's going to make it or not? So, what would you suggest?
I want to try 7.5.
Let's go. Let's plug in 15.
Oh.
That's one way to do it. Another way to do it, I think, has to go the other direction. Right here, we're plugging in an x value. What if instead we plugged in a y value?
The 10.
Yeah, the 10. What if we plugged in 10 for the y value to see if we get an x value that equals 15? Okay, because think about this. Here, let me finish writing the rest of it. Plus 10. So if I plugged in 10 and I went and solved this, and I got an x value that was 0, 0, and then I got an x value that was, 13, then that means the ball would be here and here at a height. Then you know it's going to miss, right?
Yeah.
So there's two ways we can go about doing this. You can do either or and see if it's what's more accurate. So after you solve these, what do we get? After plugging in the 15, it looks like these guys cancel out. They're the same. It equals 10.
So it's going to make it.
Wow.
So your guess would be, it's going to make it, right?
Yes.
That'd be my guess too. So explaining your reasoning, you can say, now, this is the trick with explaining reasoning. You have to explain the numbers and the math that you just used. That's all you have to do. So there's a couple of numbers that we got to explain. We got to explain why the heck we chose 15. And then you have to explain why getting 10 tells you the ball's going to make it.
Because it's
Okay, so I'm going to say it, then I'll write it. I'm going to say, well, at 15 feet away from the athlete, the ball is 10 feet in the air, which is how high the basket is. And so I'm going to assume that once the ball gets 15 feet away from the athlete where the basketball hoop is, and it's 10 feet in the air, because the ball is falling from the sky, right? It's falling above the hoop. It's gonna go in, it's gonna make it. So I would just say that. I would say because it's 15 feet away, the height of the ball is 10, then the ball is going to make it into the basketball hoop. Okay, so this game was being played in a gymnasium that was built a long time ago. There is not much room, as there should be, to allow for a high arcing shot. Oh, I hate gyms like that. Don't you hate gyms like that? I think it's worse for volleyball players than it's basketball players, but unfortunately, the ceiling is a paltry 16 feet high. like measly. Yeah. Is there any chance the shot that was taken misses the ceiling and does in fact have a chance to go in?
Yes.
Huh. How do we know this? How do we know how high the ball's going to go?
Vertex.
Ooh, the vertex. The vertex is the highest point of the arc, right?
Correct.
So if we find the vertex, then we can find out how high the ball goes. Then we know if it actually hits 16 feet.
So now we'd use 7.5, I think.
Yes.
Okay.
So 7.5 would be the middle point, right? But yeah, and I think we could do that. I think to prove that it is the vertex, I'm going to use negative b over 2a though. So the middle x equals negative b over 2a. So that means we got negative, what was that? What's the b? 1.5, negative 1.5 over 2 times negative 0.1, right? Right. Okay, so that would be let's be a positive, and we get 1.5 over is that 0.2? Okay. Now I could do this fancy little math trick. I don't know if you guys care this. I don't like decimals inside my fractions. So if I multiply top and bottom by 10, I get 15 over 2. Yeah? Yay. Okay, I like that too. All right, then we divide that, we get 7.5. Very nice, Shane. Okay, so we know our middle x is 7.5, which means we can use that to find our highest point, the y value of the vertex. So we go negative 0.1, we plug in 7.5 squared, then we're going to add to that, what was it, 1.5? 1.5 times 7.5. Oh, this stinks. Look at all these dumb decimals.
This is going to be on the test.
Okay, yeah. All right, so what is 7.5 times 7.5? I'm going to have to do that stuff on the side. All right, so I got 56.25, and that's negative. Now, what is 7.5 times 1.5?
Wait.
All right, dang, I got to multiply that too. Boo! 11.25. Oh, I forgot. We have to multiply this by 0.1. Oops. I almost made that mistake. All right, thanks for catching it, guys. 11.25.
Yeah.
And then we have plus 10. All right. So we have negative 5.625. Right? That's what we get when we multiply this by 0.1. And then we have our 11.25 plus 10. Okay, that's going to be, 21.25. Uh-oh. Plus negative 5.625. What do we get? I gotta subtract that. All right, so we got 15.625 feet. Okay, that's huge right there. So is this ball gonna make it?
Yes.
Okay, now you guys who are very literal and critical, you're thinking, well, wait a second.
Oh,
Is the measurement from the center of the ball?
The center.
Or is it from the top of the ball?
That's why they gave us the
Oh,
diameter.
that must be why they gave us the diameter of the ball. So you can be like super critical. Oh my gosh.
No.
Oh my gosh. Okay, now this is, what are the units of this 15.625? What are the units here? That's feet. So 0.6 of a foot is how many inches? It's more than 6 inches. And what's the diameter of my ball? Okay, the diameter of the ball is 9 inches.
75.
So this is 9. That means if the center of the ball is at this height, this is only like half of this is 4.5 inches, right?
Correct.
And half of a foot is more than that. So is this basketball gonna make it?
No.
Nah. This ball's gonna hit the ceiling. It's gonna hit the ceiling. So
Because it's a fat ball.
so we gotta explain our reasoning. We can say the center point of the ball is 15.6 feet off the ground. And wait, is that right? Yeah, because 16 feet off the ground is where the ceiling hits. So we only have, like, if this was 15 and this is actually at 15.6, we don't have much space right here. Wait, does it hit? Oh, you know what? I'm confusing myself. Let's draw some stuff, okay? So the ball is up here. The center of the ball is 15.6, right? And the ceiling is 16. So, if the center of the ball is 15.6, how much of this space is right there? So what is 16 minus 15.6? What is that? What do you get when you subtract that? 0.4? Oh, wait. So we have 0.4 of a foot of clearance right here.
That's inches.
Oh, this is 4. Wait.
That's inches.
It's not inches, it's centimeters. Oh, wait. Yeah, it is inches. You're right. So this is 0.4 feet, which is approximately, I don't know, it's approximately 5 inches, right? And we have how many inches that we need? Oh, I think it does clear. Okay, so it might look like it does make it, but we are doing rounding. Oh my goodness. We are rounding, therefore our answer might not be as exact. Guys, there's an argument to be had here. I think you'll find that the top of the ball is actually pretty much exactly 16 feet high off the ground. So it depends on how detailed you get here. You just got to make your argument for whichever one that you think. All right, so now to graph the path of the basketball, let's use all the things that we found. We found that at 0, we're 10 feet high. And what are we counting by here? 1, 2, 3, 4. Okay, so we're counting by twos. That means right here is 10 feet high. And then at 15, we're 10 feet high. So I can put another dot right here. At 7.5, which is right here in the middle, we are just below 16. That's the center of the ball. So your graph would look something like this. There is the path of the basketball. Oh man, what a debate we can have about C. Just make sure you guys explain your reasoning on why you think it is going to make it or it is not going to make it.